All right, so today we're going to talk a little bit about what microcontrollers are and a little bit about how to program them and why they're important to us. First, I just wanted to go over a couple of ground rules for the class, though, especially about talking. So I find that it's distracting to me if other people are talking while I'm talking, and I find that it's distracting to other students as well. So I would just request that you guys not talk while I'm talking. If you have any questions, by all means put up your hand and I will try and call on you as soon as I see you. And when that happens, you're more than free to ask me anything you want. Also, if I ask you guys a question as a class, you can put up your hand or you can blurt out an answer at that point. That's totally fine. Just in the middle of class while I'm speaking, please refrain from chatting with your neighbors or anybody else, okay? That way, hopefully everybody will be able to concentrate, okay? So, any questions about that? All right. Cool. So then, guys, remember what I said? All right. Thanks a lot. All right. So let's talk a little bit about what microcontrollers are. Microcontrollers are little tiny computers that have all of the pieces that they need together in one place. So if you guys have ever looked inside of a desktop computer, you might have noticed that it has lots of different components. It's got a processor, which does all the computations and the thinking. It's got memory, which stores the programs that you write and stores other information. It's got a hard disk, usually, which stores programs and larger pieces of information. And then sometimes it has input and output devices, like Ethernet cables or input-output that goes to a computer monitor or things like that. So all of these different components work together to make up a computer. A microcontroller is usually a board that has all of these different components together in one place. There are many different kinds of microcontrollers, and I brought a couple of examples with me to show you. The one that we're going to be using is this one. This one is called, the chip on here is called the Propeller chip. It's got 8 different cores, so this is the processor. The board itself is called the Propeller Board of Education. So the board contains many other components. It contains an EEPROM, which is the memory that stores the programs that you write and other information. It's got digital to analog converters, which allow you to create analog outputs from here. It's got analog to digital converters, which allow you to read analog signals in from the outside world. And then it's got a terminal for a Zigbee chip as well. So this chip is the processor. It's got 8 cores, and then this board altogether is the microcontroller that we're going to be using. Okay? So I'll pass this around and you guys can take a look. There are many other examples of microcontrollers as well. Yes?
How much power is needed?
For one of those, I don't know exactly the wattage that we're talking about. The batteries that we use, it'll take a voltage supply that's somewhere between, I think, 6 and 15 volts.
Okay.
But I don't know exactly how much wattage it requires. Yeah. Other questions? Yeah.
When you say digital to like analog, are you talking about like if I have like a signal going through digitally and change it to like sine waves or something like that?
Yes, exactly. So there are generally 2 kinds of outputs that you can have. You can have a digital output or an analog output. A digital output has only 2 states usually. It's got high or a low. So you can think about it as either a 0 or a 1. So with a board like this, a high output is usually about 5 volts, a low output is 0 volts. So if you're talking about digital outputs, it can either be 0 volts or 5 volts. Analog outputs have a much wider range of output values that they can take. So like you said, a sine wave is a good example of an analog signal. It can be high or it can be low, but it can also have many, many values in between. So when we say that we have a digital to analog converter, what we're saying is that we take a digital number that's coming out of the microcontroller, so a number like 527, for instance, and then we turn that into an analog voltage, which is somewhere between 0 and 5 volts. So that's what a digital to analog converter does. And then an analog to digital converter does exactly the opposite. It takes an analog signal that comes from the world around us, and it converts that into a digital value, a number that the computer can read. So it'll take an analog value and then convert it to some number. So, yes?
Why would you want to do that?
Well, so there are many instruments that provide analog readings. So for instance, you might have a thermometer that's measuring a temperature, and the output from that thermometer might be a value between 0 and 5 volts. So maybe 72 degrees corresponds to 3.7 volts. So then what you would want to do is you would want to use, if you wanted to measure that with your microcontroller, you could use an analog to digital converter to take that analog signal and then turn it into a number. And then you could do some processing with your computer. You could maybe record that to a database or publish it to a website or something like that. Mm-hmm. Yeah. Other questions? Okay. Cool. So that's one type of microcontroller. There are many others. You guys may have heard of something called a Raspberry Pi. This is a Raspberry Pi board right here. This, again, has many of the same components that were found on the other board. It has a processor, it has memory, but the components themselves are slightly different versions. So that processor on the Parallax board is a Parallax Propeller processor. This one is a Broadcom processor. Okay? That board has analog to digital outputs. This one does not, but it does have an Ethernet port on here. And it's got a port to connect, it's an HDMI port to connect to a monitor. So this is another example of a microcontroller, and you can use them for different things. So that Propeller board that's going around does not have an operating system. That means that it can only run one program at a time, but it runs in real time. So if you want something to happen at very precise fixed intervals, you might use the Propeller board. Also, the Propeller board has 8 cores that can run at the same time. So if you want to do 3 or 4 things at the same time and have them actually going on at the same time, you might use the Propeller board. For instance, you could have, if you were driving a robot, you could have one processor that was monitoring and looking for other robots nearby. So that could be like the monitoring processor. You could have another one that was driving the wheels and creating the PWM for driving the wheels. You could have another one that was the main controlling loop that was making all the decisions that you want. So you could have lots of different things going on simultaneously. So that would be one use for the Propeller board. Whereas the Raspberry Pi does have an operating system. This one runs Linux. And Linux allows you to run several different programs, and you can actually have a desktop that you can see on this. So you could hook this up to a monitor and it would have a desktop, just like a Windows desktop that you might see. So this could be used if you wanted to connect to the internet and you wanted to publish data. In fact, we're doing that to publish some weather station data that we're getting from the roof of the building next door. We're using a Raspberry Pi to do that. So each microcontroller has their own advantages and disadvantages. Strengths and weaknesses. Yes.
Is the processor
Yes.
same as the cell phone or different?
I believe that Broadcom makes cell phone processors. I'm not sure if that one is used in cell phones, but it's very similar. Yeah.
Could you use these two in conjunction with each other, like in a
Sure,
device?
sure, yeah. And that's actually done quite often. So you might have one microcontroller that's very good at real-time things that is in charge of handling real-time tasks. And then you might have another one that connects to the internet, or that has sort of higher level processing power to do, that can do decision making and things like that. And then they can communicate with each other in various ways. Yeah?
So can the Raspberry Pi be fitted with like Wi-Fi or
Yes.
something like that?
Yeah,
Bluetooth?
exactly.
Oh,
They,
nice.
they can. The older versions have the USB ports where you can plug in a Wi-Fi dongle, and newer versions actually come with a Wi-Fi chip built in.
That's cool.
Yeah, and Bluetooth built in fact, as
Yeah.
well. So you can even communicate with them over cell phones, things like that.
Is that a
Yeah,
Pi or is that the, or that's the Raspberry Pi then? Okay.
yeah, the Raspberry Pi. Yeah.
So this is a little off topic, but for the final for the end of the year, could we use a Raspberry Pi in our assignment?
So you're
I don't know how much
allowed.
it costs. That's it.
Right. So you're allowed to add on anything that costs less than $20.
Yeah.
It's actually possible to order the Raspberry Pi Zeros for $5, I think, or $10.
They're $5.
They're $5. Yeah. So it would take a significant amount of coding and extra work on your part, but if you wanted to do that, you could add that on. Now the robots themselves are supposed to be autonomous.
So you can't like
No,
I was
you
thinking about,
no,
like,
right,
zoom
right,
in.
yeah, no,
Real glass.
right. But if you wanted to try something out, you're more than welcome.
Okay.
Yeah.
Mhm. Yeah. So I brought a couple of other examples of boards to show you guys as well. This is
Boards, show me some boards.
yeah. This is a souped up version of an Arduino. This is made by Galileo. It has an Arduino chip on there. It's also got another chip that runs Linux. So this is sort of like two different processors working together.
Ray can give us a game board.
So this is two processors on the same board that are working together. And they're sort of communicating with each other just on one board. So that's one thing. And then this one is called a BeagleBone. This one runs Linux. This is sort of meant to be a sort of like a little web server that can obviously be in a very small form factor. So yeah, it's got Linux on there. It connects to the internet, and then you can run run programs on there for Linux. And then finally, this is something else that Parallax built. This is the same Propeller chip that was on the board that we're using, but they added on some extra features here. So this is actually a little name tag that Parallax made for a conference at one point, and they just took their chip and they put it on there and they added some extra features. So if you shake it up and down, it makes the lights go back and forth. If you push this little, if you put your finger on this little symbol right in the middle, it acts like a button, and then it would actually send contact information from one badge to another.
Wow.
So if somebody else had one of these badges at a conference and you pointed them at each other, you could exchange contact information almost like a business card. Yeah.
How do you download it later?
There is a USB port on here, and yeah, you can
That's so
connect
cool.
there. Yeah. So I'll pass that around too. So those are just a couple of examples of microcontrollers. There are many other microcontrollers out there as well, but those are just a few examples that I brought with me. So like I said, microcontrollers are basically systems on a little board. They have a processor, memory, sometimes input and output devices, and they package everything up in one small board, and they can be used to control robots and things like that. That's why we are interested in microcontrollers, because we're going to use the Propeller board WX to control our robots. Okay? So we're going to talk a little bit about how that's going to work today. We're going to actually learn about how we can write programs for the propeller board. Okay, so we're going to start with the programming today. We're going to continue on over the next several classes and learn more and more about the programming. And then by the end, you should know enough to be able to write a program to make your robot follow a line that's on the ground. And that's going to be the midterm, remember. There's going to be a track on the ground, and you're going to program your microcontroller to follow that track. So we're going to start learning about programming today and continue over the next few classes. Yeah?
So the track's on the ground.
Yeah.
Are we actually going to determine what moves it needs to make and program it in, or are we actually going to have a line sensor?
You're going to have a line sensor. Yeah, and we'll talk about the sensors in a little bit later on as well. Yep, so there will be a line sensor though, and it'll give you a reading to tell you whether it sees the line or not, and then you'll have to decide whether to turn or not based on that reading. Okay? And we'll talk a lot more about that and make sure that everybody is clear about that before the midterm. So let's go and talk a little bit about how we can actually program these microcontrollers. Just like there are many different varieties and flavors of microcontroller, there are many different ways to program them as well. There are many different languages to use and many different environments that we can use when we're programming. Okay? So the way that we're going to program the Parallax microcontroller is through the Parallax website. So what we're going to do is we're going to go to blockly.parallax.com and we'll log in. Everybody is going to need a login, an account with Parallax in order to program it. So you sign up, you can just give them your student email address, and then they will create an account for you. And then they will store all of your programs in one place, and you can get to them from any computer that is connected to the internet. So, the other thing that we need to do is we need to run the Blockly prop client. So this is a program that should be available from your desktop. Double click on that and run it, and that'll actually allow your computer to connect to the stamp. Okay? So we'll have to run that, and then we're going to program the stamps using a USB cable. So everybody will grab a USB cable and connect that up. So I'm going to need to borrow that Parallax board. Can I? Yeah. So this is what it is. Yeah, we'll be able to see it a lot more when we are over in the class. Everybody will get to play with one. So we're going to plug it in, turn it on. And then we'll say connect. So this allows the computer to connect to the board. Okay. Now, in order to actually program the chip, what we're going to do is that we're going to create a new project. So you come up here, you click on New Project. You can give the project a name. You can call it whatever you want. We'll call this Link Test 193. The board is going to be a propeller activity board, WX. Okay, so
What kind of board was it?
so it's not happy about the board. What's that?
What kind of board was it?
This is a propeller activity board, WX. Okay. So I will. So it looks like it's not going to accept programs right now, but that's okay. I will show you how to write the program, and then we can work with that. So what we're going to try and do is we're going to try and make an LED blink on and off. Okay. So that's all that it is. What we're going to do in order to do that is that we have to make a pin go high and a pin go low. So a high voltage is going to turn the LED on, and a low voltage is going to turn the LED on. Turns out that there are actually a couple of pins that are built in that are already connected to LEDs. So pin 26 and pin 27 are already connected to LEDs. So what we're going to do is we can just set a pin state. Okay? So the way that this editor works is that it's not quite the same as other programming that you may have seen. With other programming languages that you may have seen, you have to type out a line of code and then tell the computer what to do that way. This programming editor works a little bit differently. This one just has the commands built into little blocks, almost like Lego blocks. And then you snap the blocks together in order to form a program. So in order to make a pin high, you come over to the pin states menu, and then you choose this little block that says make a pin high. Okay? So for this one, we're going to choose pin 26 because that's connected to one of the LEDs, and we're going to make it high. Okay? So that's all you have to do in order to make the little LED light up. Because that one block contains all of the instructions that you need. So once you put that down, it'll actually make the light turn on. In order to send the program over, you click on this load and run the code. Okay? So when you click on that button, that will actually send the program over to the microcontroller. Okay? So that is all that you have to do. Now, that's just going to turn the light on. That's not going to make the light blink. We really want the light to blink on and off. So we have to turn it on, but then we also have to turn it off. So how do you guys think we would make the light go off? Yeah. Yeah, exactly. We can grab another one of those. So we can come over here and grab this one. So then what would we have to change about this one? Yeah, we'd have to set it to low, exactly. And we'd have to make the pin the same pin. Now,
what's that shiny chip on this?
That's, I think it's a process. Yeah. So that's a great question. And yeah, so if we just have the program run like this, we turn the light on and then we turn it off immediately, it's not going to stay on for any visible amount of time. So you wouldn't even be able to see that the light went on. So what we need to do is we need to actually have a time in between these. To do that, we come up here to control. And then we use this pause function. And the pause tells the program to wait a certain amount of time, and that delay is given in milliseconds. Yeah?
Is there a maximum or minimum amount of time that you can enter on there?
0 is the minimum. The maximum, I don't think that there is a maximum. One thing though that you can do is you can right click on any of these blocks and you can click on help. and that'll bring up a whole page dedicated to that block, and it'll tell you more information about it. So this is all of the functions that are in the control section. So here we have the pause block, and it doesn't specify any maximum amount of time. So I'm not sure.
That you can't put a fraction in there, so 1 millisecond is the lowest.
Right.
Time.
Yes. Yes.
Jordan Mayer,
Yes.
we're picket 3.
I'm sorry?
I got picket 3 on 2. I got Parallax, I got a couple Parallax Propeller chips.
Uh-huh.
Picket 3, and I got a Arduino Uno.
Oh, okay. So those Picket 3 is another kind of microcontroller?
Yeah.
Okay.
Oh, I can bring it over. Yeah, next
Yeah,
time.
bring it in sometime. We can check it out.
Yeah, it's good. It's small, and it's got this little orange thing that has like little lights on it, and you plug it right into it.
Okay, cool.
And it's also, you can solder wires on it. And
Okay.
I also got a one of those Xylix, board, big, one of those,
We'll bring it in sometime and we'll take a look. But right now we're going to move on. So in order to make the light blink, what we have to do is we have to turn it on, wait, turn it off, and then we have to wait a little bit more in order to have it off for a certain amount of time. So we need to get another one of these pause commands. So we could go back to the control and find it again, or we could do it another way. We can right-click on the block and say duplicate. And that just makes another one, and we can drop it down at the bottom. Okay? Yeah.
Is there any way of doing this as one statement without having it to break up into so many small parts? Like one line.
So
I thought I saw one of the controls for the pin set as had its time set in it.
So, not that I am aware of. I believe that you need to. So there. Yeah, I don't think that there's a way to do it just as one statement. If you find one, let me know. But I haven't seen it. Yeah.
Is there any paid subscription to make an account with Parallax?
No, it's totally free. Yeah. Yep.
God, I just hope they don't go out of business.
No, they're a great company. Now, the last thing that we want to do is that we want to make this happen over and over again. So, in other programming languages, we do that with something called a loop. And we do the same thing here. But in other programming languages, we write one command at the top to tell us that the loop is starting, and then one command down below to tell the program that we've reached the end of the loop. Here, we can just grab one block, which is the loop all by itself. So we can just grab this block that says repeat forever. So that is a loop. And then we drag the code that we want into that loop. And then it's as easy as that. Okay? Yeah, so that's like a do loop that you might have seen in PBasic. So this will just repeat our on and off code forever. Okay?
That actually kind of solves my question. It does make it as one statement for the loop set, but
Yeah.
next one makes it pretty well.
Yeah.
So, could you make it repeat maybe a certain amount of times and then add stuff to the bottom of it?
Yes. So if you wanted it to repeat a certain number of times, you just click on this menu, and instead of choosing forever, you would choose X times.
Yeah, nice.
So then, if you wanted to do that, you would have to tell it how many times. You can come over here under Values and grab one of these little numbers, drop it there, and then put in whatever value you want. Okay?
This is so much easier.
Right. It really is a lot easier than many
cool.
other programming languages.
Yeah.
Because you,
Yeah, I can see.
Because I did PBasic. I had to do robot connected driving. This is so much easier.
right. It's a lot faster, and you don't have to count how many open and closed parentheses you have. And yeah.
Is that procedures for the learning robot the same as used in the industrial quality?
So You're asking whether the stuff that we're doing is similar to what is found in industrial.
I think the stuff is a little bit different from memory programming.
Right. So it's very similar in that there are all the same components. So our robot is going to have a microcontroller that makes the decisions. Industrial robots will have microcontrollers that make decisions. Our robots will have motors that move, and so will industrial robots. As far as the actual language that is used, there are some differences. We are using this blocky prop language because I think that it is fairly easy to learn, and it also teaches the fundamental concepts that are in almost all programming languages. So this is not the language that is found in many industrial computers. Many different companies have their own language. So like Festo would have their own language, and lots of different companies have their own language. So we're using this language to learn the basics of programming, and then you can apply those concepts to any other language that you might find. Yeah.
Do you know which language is the most commonly used?
Well, like I said, each different company typically has their own sort of language. So,
Yeah.
so if you're working at a company that's using robots made by Epson, for instance, then you would use the Epson language. If you're using robots made, by Mitsubishi, then you would use the Mitsubishi language. So each one is a little bit different, and I don't know that there's one that's most common.
So you have to learn where to go if you want to go with the one.
Yeah, exactly. So what I want to do is teach you the basic ideas, and then you can apply those ideas to whatever specific language you're going to be using. Yeah.
Is there a way to annotate that or to leave a note?
Yes. So you can right-click on here and let's see.
Oh, it's at the top.
Yeah, there we go. So add comment. So you can drop that down, and then you can type in a comment here, and then you can either just leave it nearby, or you can actually put it in line with your code. I thought that there was a way to right-click and put something in as well, but I don't see that. So yeah, you can use comments that way. Yeah.
What does the collapse block do? If you right click on it, it gives an option to collapse block.
So
It just hides the values and all that stuff and just makes it so you can't change it.
yeah, so I guess it makes it a little bit smaller, and right, like you said, you can't change it right away.
I think if you hid the loop, it would hide everything.
Yeah. Okay. So
That makes it a lot cleaner.
cleaner or hard to read? It's sort of a matter of opinion.
Well, the color on the outside of it, so no one is like.
If something like
Yeah, you might want
this
to put a comment on the
big,
outside after you collapse it.
Yeah, there you go.
It all
Right.
has to do with
Yeah.
style.
So, and then you can expand it again. So, yeah, so you can play around with that, and if your code was getting really large and you couldn't see it all on the screen, then that might be one way to shrink it down a little bit. Yeah. So that's the general idea. That's how you can program a microcontroller to make a light blink on and off. The other cool thing about this is that what's actually going on behind the scenes is that the website is taking your Blockly code and turning it into C code. And then it's actually compiling the C code and sending that to the microcontroller. So if you are familiar with C, or if you want to learn a little bit more about it, you can actually switch back and forth and view the C code that's being generated. So you can click down here, or I'm sorry, you can click on this button that says code, and that shows you how you would write the same program in C. Okay?
And that comment, yeah, okay, it included the comment
Right.
that you put in.
That's cool.
Yeah, exactly. Now, you can only edit the code from the blocks view. You cannot edit this C code, but when you edit in the blocks view, it changes this code. Okay? So it updates that automatically.
Once you've done everything you can do in Blockly, you can export this and continue changing it in C or not?
Yes, that is correct. So there is a separate editor that will allow you to type in your own C code and compile that and run that on the chip. Now, we're not going to be using that editor in this class, but if it's something you're interested in, you can do it. The editor is free. There's a lot of documentation out there to help you, and you can, like you said, you can write most of your code in Blockly if you like, and then export this into that other editor and then compile it that way. Did you have like a follow-up?
It's a different question. Go ahead.
Okay.
Oh, I was just wondering if you could, if you wrote C code somewhere else, could you import it into Blockly and then edit it later with the blocks?
Unfortunately, I don't think it works that way.
Okay.
Yeah. 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 Did you have another question?
Yeah. This is kind of off topic.
Okay.
There's a lot of code out there,
Right.
and anything that you want to do, maybe somebody's tried to do it before.
Right.
If we use some of that,
Right.
there's usually a block in there that gives credit to the person who originally wrote the code. Is that block is sufficient to avoid plagiarism or? That's a question. It sounds like
Right.
a statement, but it's a question.
Right. So, yeah, in terms of like getting credit for this class,
No,
or in terms of-
credit worries me less than getting thrown out for cheating.
Right. Right. Yes. Okay. No. If you want to use somebody else's code, talk to me about it, and
Okay.
we can go through it and check and see. I mean, if you're
Okay, so your intent is to write the whole program.
yeah,
Okay.
and I will give you code to start with, and so you're not going to be totally on your own. If you want to add on to it, that's fine. If you want to use somebody else's library that does a particular thing that you think is cool, talk to me about it, and it's probably okay. I just want to
Yeah.
run through it ahead of time. Yeah. Yeah. But like you said, there are many different libraries available. Many different people have worked on this sort of thing before. So so that's a good thing to look at. Yeah. Other questions?
Somebody starts from slow.
Yeah. Oh, yeah. Just hang on to them for now, and I'll grab them in a second. Thank you.
You know what's funny is when I was doing my daughter, is I got those electronic playgrounds. So I've been doing is have my daughter so we can hook up some circuits.
Oh yeah.
And it's like, hey, you have to start from silver in order to learn electronics.
Yeah. Absolutely. Absolutely.
You know, like wire a light bulb through a battery or something.
Yeah. So that is what I wanted to talk about today. So the lab for today is to make a light blink on and off, and then when we do that, I'll come around and check you guys off and give you credit for it. Now, I saw that when I tried to run this code, it said that I had the wrong version of the Blockly prop installed on this machine. So I have a strong suspicion that the wrong version is going to be installed on the other machines as well. So I think that the lab is not going to, we're not going to be able to do the lab today. So I apologize about that. What I will do is I'll make sure that the correct version gets installed for next time, and then we can do the lab on Wednesday. So I think we're going to have a free period and not do the lab this time. Yeah.
What is the corrected version called?
So it said, so let me, I believe it's blocky prop 0.6, and I had 0.5 installed on here.
Okay. Is it,
Yeah.
is it the client doesn't communicate with the website, or the client's not communicating with your board?
So,
Does it look like you can install an update?
yeah, but I am not an administrator on these computers, so
we're-
I
yeah, we're not gonna do that.
So it's,
See, yes, that.
That's.
yeah, so we just got the wrong, I think Parallax just updated their software on their side, so that's why it's not working, yeah.
You could still do the lab, it's just writing a line of code, and it's a pretty simple set of code as long as everything matched up. But you wouldn't be able to test, but you'd be able to at least do it.
Yeah, so you're welcome to try that. I will be over in room 308 this time. We're sort of having a round robin. We're trying a new room each time. We'll be over in room. No, I take that back. We'll be in room 320 like we have in the past. So that's the room that we go in for ET 302. If you guys have been in ET 302 before, so we'll be over there. If you want to try it out and play with the editor and write the code, you are welcome to do that. I have a feeling that it won't download to the boards, but we can try it anyway. Yeah.
Oh yeah, you can solder wires in this thing.
Yeah, with that particular board you can. So you can also access the editor from any computer that's connected to the internet. So if you wanted to try this on your own, you can do that as well. So I'm going to take attendance, and then I'll head over to room 320, and if you guys want to come over there, you can. Otherwise, you're free to go, and I will see you on Wednesday. So let me take attendance first.